I'd like to take a moment to go over the concept of email encryption with you. Sending sensitive content via emails can be a violation of the company's policy. Additionally, we're in a conversation about security. You and I would like to communicate securely. How do we do it? Can be tricky. When we look at solutions like WhatsApp has had some privacy issues we've seen previously. I'm not going to use Facebook Messenger. SMS is susceptible to some interception. So I go, what do I use as a secure messaging mechanism between different parties? Depends on your organization, depends on what your requirements are. But when we look at email and the way that we can actually make it a bit more secure, we can apply encryption to our email, either as it sits there, like before we send it, or while we're sending it, actually passing it between different servers. In this section, we'll take a look at some differences between what we call Cisco's Registered Envelope Service, which is Cisco's email encryption. We'll take a look at the way that TLS/SSL has been associated or applied with a lot of our standard protocols. So we'll see that POP3, S, IMAP S, SMTP S can be leveraged. It will also show that SMIME can be applied to your email itself, and that can be a pretty good way to give us end-to-end encryption. And I know all of the requirements are different, so it's good to know about all three and see what mechanism is going to fit your needs the best. So let's start off by taking a look at the Cisco Registered Envelope Service. Basically, you've got a user that has a Cisco ESA, and they have a message that needs to be encrypted. So they go ahead and send it to the ESA. ESA knows that it needs encryption, right? So it builds an encryption key and then sends the encryption key to this key server, and where it's basically going to be hosted. We basically send a link to the user, or the recipient, I should say, and we go, hey, you've got a secret message here. When they use the link to open the message, they'll typically authenticate or prove themselves in some way. If nothing else, we go, at least we know only the person who has this message can click the hyperlink. But a lot of times this will tie into an auth function where the user authenticates, and then once they authenticate to prove they are, they get the message key. Once they have the message key, they can decrypt it. So kind of a neat mechanism for providing email security. If we take a look at what's kind of happening under the hood, whenever we're transferring emails from one place to another, if we're just sending it over TCP port 25, that's in the clear. So anybody who's got the capabilities to get into, say, a provider network and look at a link between two routers, or anyone that has the ability to influence a provider network and get traffic to come towards them and then back out of them, has the ability to analyze everything happening over TCP port 25. I doubt they're going to do it in Wireshark, looking through packet by packet. You'd create rules that filter that traffic and sift for specific types of information. Just like we can use regular expressions to do DLP, other people, scumbags, could be using those same types of rule sets to comb through and parse our emails. To protect from that, because the internet is pretty hostile and the routes are not set up like they should be, people could potentially get access to this data. So I'd say the internet, when we pass traffic across it, don't think that it's trusted. Anybody at any of these providers could get access to your data. The best thing that we could be doing is encrypting the communication hop by hop or between our mail servers, leveraging TLS, right? By doing so, whenever you connect over SMTP, you can actually tie TLS into it, and then we perform our regular SMTP communications with the codes and everything that we looked at previously and commands. That would all happen, but it would happen through a TLS connection. So really not a unique strategy. I feel like TLS has been applied to almost all of our protocols to go, okay, here's the old one, and then here's the new secure version. So just realize that we can leverage TLS as a communication mechanism. Can be used for relaying traffic as well as what we saw with the Cisco Registered Envelope Service. When we take a look at SMIME, SMIME is basically built just for working with email. When we take a look at SMIME itself, basically stands for Secure Multi-Purpose Internet Mail Extension. And it effectively gives us a way to leverage public keys and private keys when we exchange the emails. Like in this scenario, you've got Bob and Dave. Imagine that both Bob and Dave created an RSA key pair. So private and public here, and private and public here. Now, don't think of these as digital certificates. We're just thinking of these as individual keys. Your private key is hidden, it stays with you. The public key is for the world. Same thing over here. Private key is hidden, public key is for the world. If Dave and Bob have one another's public keys, Dave can take an email message, he can encrypt it with Bob's public, which is going to create ciphertext. That ciphertext can be relayed, and now, since it's been changed to ciphertext, we can use SMTP, clear text over port 25. We don't have to leverage necessarily like SMTPS or TLS connections between mail relays, because the mail itself is encrypted. We're not leveraging the ESA and making it do funny things with envelopes and hold keys, again, because this is between the two users. We can do this from business to business between different relays. We can also do that from business to customer or customer to customer. So again, Dave and Bob trying to send emails to one another, you take that email and you encrypt it with your public key. I'm sorry, with your private key. That creates ciphertext. That ciphertext can only be decrypted by the public, which of course Bob has. And in reverse, anything that Bob wants to send out, he can encrypt with his private key, and then whoever has Bob's public key can decrypt that data. Hope that makes sense. So the ESA supports using encryption to secure both inbound and outbound email. Encryption itself needs to be turned on globally, and then we can create policies to talk about the way that we want to perform encryption. When we leverage a key server, it can either be used for the Cisco Registered Envelope Service managed service, or it can be set as what we call a Cisco encryption appliance, where it's basically a locally managed server. We're not doing anything with third parties. The Cisco ESA encrypts messages and stores the keys on a local key server or a hosted key service. It's got the capability to do either, as we mentioned 2 slides ago. The message encryption itself is going to be determined by message filters, content filters, and again, because DLP is only applied to outgoing mail, also DLP policies, but of course in the outbound direction. So what happens, traffic comes in and we go, oh, that's got a sensitive word in it, that's got, something that we need to basically take an action on. We've got that condition. Instead of using a DLP condition to potentially drop or notify or forward it to an investigations mailbox, in this case we're going, oh, this is traffic that has an encryption policy, we should just protect this particular data. So it's not a lot that the user has to work on or configure or really think about. The Cisco email encryption process includes several steps. So the ESA encrypts the message. Again, that message is going to be stored in a server. Whoever receives the message, here's this encrypted message sent to the recipient. They're going to have to authenticate to the key server, retrieve the key, and then of course that encrypted message can be displayed. So to make all this happen, we need what's called an encryption profile. And this is going to give us our if and then condition for, okay, if I see traffic like this, this is how I want to protect it. The encryption profile, once it gets created, is going to be nested inside of other things like message filters, content filters, and DLP policies. And then within the encryption profile, all we're doing is setting who's the key server, how are we handling the envelope, how are we handling the messages, how are we handling the notifications. There's going to be various attributes and options that you can select for each of these. And then once we select them, we store those settings in this encryption profile, again, which is just going to be nested inside of your other policies. When we look at content filters for message encryption, the content filters can be used to determine which email messages should be encrypted before being sent. A lot of times when we've been discussing things, we said, hey, we want to identify viruses, we want to identify malware, we want to identify marketing that's going to be a waste of our time and throw it away. So much has been about throwing it away. I think this is a little bit interesting. It's a nice change of pace because we're talking about forwarding it and making it better than we found it. So instead of just taking stuff and throwing it in the trash can, we say, hey, let's wrap it in some armor. Again, we can encrypt on delivery, we can encrypt and deliver now, we can leverage SMIME. So SMIME is something that could actually be deployed on the end user's workstation, or it could be deployed, of course, on the ESA. A lot of times what we're looking at is how do we make this really easy for the user. If the user's stuck in webmail all day, they're just using HTTPS. Even if they're using Outlook, there's a good chance that they're doing communications over HTTPS. So from the user, and I probably use Exchange more than I should. For my example for the mail server, there's other ones out there. But the user connects to Exchange. This may all be happening over HTTPS. Slash, what does that really mean? That it's using TLS under the hood. So there's no problem with the sensitivity of the data from here to here. What happens is when Exchange relays it, it's going to send it to the ESA, who's responsible for enacting all of our policies. How does this communication fare? Is it protected? Are these two boxes on site? Are they in a secure facility? If they're in different locations, what's happening to that traffic when it gets passed from one to the other? How many people, my little person here, looking at this traffic, how many people have the ability to analyze this traffic between the Exchange server and the ESA? So this is somewhere where we can actually add encryption. Now, once the ESA does all of its checks and it gets into delivery, of course, that's where you do the MX record lookup for the other domain. What's going on with the communication here and whoever your MX record points to? Is this going to be encrypted? So this is where we can apply policies. If we're not doing this, from user to user, actually, configuring public and private keys in their inbox on their local mail client, we go, okay, I'm pretty sure it's protected to Exchange, but let's look at this on kind of like a stage-by-stage basis. I'd say stage one, just in the Exchange handoff, is this protected? And you might say no, and it doesn't matter because it's all in my DMZ. Fair enough. If that's the way you feel, maybe you don't think that you need to encrypt it. Next, we go, okay, stage two, assuming that it makes it through all of our filters on the ESA, what happens when this traffic goes out? And again, we can protect it between us and the next mail exchanger. If that doesn't work for you, if you're connecting to MX servers that just don't support any type of protection, again, that's where you can come back to using something like that envelope service. So we've got a lot of different options, that are available to us. Should one thing fail, that we can kind of fall back and use another. And malicious agents can intercept communications going over enterprise mail gateways. That's kind of what I've been talking about with the man in the middles. And I go, when we look at these emails, what's really going on with them? If I go to Facebook, eBay, other big sites, my bank, whoever, and I say, hey, I want to log in, forgot my password, and I set a request, they're going to generate a specialized link for me and mail it to me. So what happens if I visit that website, I punch in your credentials, and then I sniff email traffic? Is this email being handled in a way that I've got the ability to eavesdrop? If I can get the password reset link. And if it's the weekend and you're out doing stuff with your family or your friends and you're not thinking about all this, you don't see it till Monday morning, you're like, wait, password reset link? I didn't reset my password Sunday morning. It's too late. So just things to think about. When we look at the ESA, it supports different TLS certificates. It could be placed on your public and private listeners, the actual SMTP service. It's also going to have TLS for doing HTTPS. When I log into the ESA to manage it, I'm doing so using my browser. For this to be secure, it's got to happen over SSL, so we use HTTPS to manage it. Yet also, we can use TLS certificates for LDAP. Remember, whenever traffic comes into the ESA, we're going, okay, I accept anything at cisco.com. Here's one for bad user at cisco.com. That seems weird. Do an LDAP query to the back end. Is bad user here? No. Go ahead and discard it. Well, as I'm passing that data back and forth, is it protected? I don't know, but it can be. If so, we're just doing LDAP with TLS, which is just LDAP-S. Looking at outgoing connections, when I build a connection to another mail relay, this is where I do that MX record lookup. Does it support TLS? If so, should I be using it? If I want to use it and they don't, should I continue to send it? Again, all different things that we can think about. If using TLS is the preferred option, then using message encryption, we can use TLS on the ESA. We've got to have an X.509v3 certificate and matching private key for receiving and delivering. Why? Because we've got to be able to encrypt and decrypt as though we're the actual party doing it. Preferably, use a certificate signed by a public CA server. Because if you use a self-signed certificate, anybody you communicate with is going to get errors. Does that mean that this isn't capable of working? No, it can work. But this is also something that'll get you in a lot of trouble, because if somebody does man in the middle and they do SSL with it, we're going to create our own self-signed certificate and push it to the downstream device. If it's willing to accept self-signed certificates because you're using them in other parts of your organization, there's nothing to differentiate your certificate from my certificate, unless you manually added that one cert. So in this circumstance, if you set as an option to go through these errors, which is something a lot of web developers do when they're creating web applications and mobile applications, they build it themselves, they use a self-signed certificate, they go into the code and they say, yeah, ignore that certificate warning. They go back to adding features, shipping the product, and before you know it, you can intercept with your own certificates. So something worth trying from the offensive side, but from the defensive side, this just reinforces why we want to have our ESA set up with a certificate that's registered through a public CA server. The ESA supports root certificate verification, and that is if I trust Thought or VeriSign or GeoTrust or whoever, do I know that the certificates that they issue are actually going to be good? And this is where we can tie into also what's called intermediate certificate verification, just part of our hierarchy throughout a PKI. The Cisco ESA can use the following trusted CAs. There's a pre-installed list that it ships with, and there's a user-defined list. This gives us the ability to implement our own CA servers. That's great for certificates internally. If I've got 6 Exchange servers and 4 ESAs and it's all in the private network, fantastic. Go crazy with my own CA server. However, as soon as I start talking to things on the global internet, I'm going to want to use a public CA server. So when they say trusted, something that's going to ship with an operating system. When you're connecting to some Linux mail server, some Windows mail server, what are they going to go along with by default? And here we just see our mail flow policies. You see accepted, blocked, relayed, throttled, trusted. In the case of throttled, we're going to allow it to go by. We're just going to rate limit it a bit. But here, where it says encryption and authentication, these are our options. Here we see TLS. Here we can see whether or not SMTP authentication is required or needs to be used. Notice here that it's off, but this is something that we can either prefer or require. I can say, you know what, when you want to relay an email or even deliver an email to me, I need to know who you are. This is just an additional step to stop anybody from trying to abuse the mail server. So the ESA can send messages to domains over TLS connections, as we mentioned, and this is an alternative to message encryption. Why? Because the email itself is in the clear, but when we went to do the relay, when we went to do the SMTP conversation, we encapsulated all of that within TLS. So what we would do is enable TLS for email delivery to specific domains. Great between partners, great between yourself and perhaps acquisitions. Support for domain server, certificate verification, and again, we've got several TLS settings that can be specified. Here you see whether or not TLS support is enabled or disabled. And again, when we see TLS support here from our drop-down and destination controls, we see all of those parameters, whether it's preferred, whether it's required, etc. Last but not least is going to be SMIME, or Secure Multi-Purpose Internet Mail Extensions. Now this is standards-based, which means Windows, Linux, OS X, everybody should support it. It's based on the concept of public and private keys, but it's not necessarily a PKI. Public key infrastructures where we have a certificate authority, everybody's checked in, they've done validation of themselves, they've been issued X.509 digital certificates. This is not that. All we're doing is exchanging public keys somehow in advance, and then once we've done that, we can use those public keys to encrypt and decrypt emails. So you have public keys in your digital certificate, it's just a more polished way to handle and kind of communicate with your public and private keys. So a lot of times when we look at that digital certificate, it is your public key, but it's your public key with identity information about you and about the CA server, and there's details about the certificate, the serial number, the born on date, expiration date, revocation list distribution point, all this extra stuff. But to do encryption, we really just needed the public key. So there's mechanisms that you can use to exchange these public keys manually or out of band, and you don't necessarily have to have the overhead or the complexity of PKI. Again, there's lots of different ways to perform this. A lot of times what we'll do is leverage PKI, we'll get an encryption certificate, and then we'll use the key from within that certificate. Just depends on what it is that you're configuring and who you're trying to communicate with. So long as everybody supports that trusted third party, you're going to get away with using it. If you don't want to use a PKI, you can just use RSA public keys. We can use them for authentication. We can use them for transferring encryption keys. We can use them for encrypting data if we wanted to. Remember, asymmetric is slower, but it's still definitely usable. So here they are, just showing for throttled traffic, again, under SMIME, decryption and verification. Here we can say whether or not we want to use it. It's just got an on-off button, and then signature after processing, whether we should preserve the signature or remove it. There's additional parameters beneath it, public key harvesting, harvest certificates on a verification failure, just showing that you can also tie certificates into this, and should we store updated certificates. So here just showing that SMIME can be used in a business-to-business scenario. So maybe you've got Bob and Dave, and they've never heard of public keys, they've never heard of digital certificates, they don't know a lot about encryption, they're just sending email. But when the email gets to the gateway and the ESA could do encryption between each other. So again, this is just having SMIME set up on the delivery side. Additionally, SMIME can be used in a business-to-consumer scenario, or even consumer-to-consumer.